Hi everyone, good morning I think. I'm Will and this is Kai, and we're going to talk firstly about the camp, which many of you will have been to. We had some feedback and basically a lot of people complained that we didn't give a presentation about what we did at the camp for the network, so we thought we'd do that here, and we'll also do a quick presentation about the network you've all been using here these few days. So moving on to the first slide, quick review of what we're going to talk about about the camp network, the uplink, the hardware build-up, and some of the monitoring and the stuff we use to run the wireless LAN. So firstly, the uplink to the campsite is quite a challenging. It's quite challenging to get that kind of connectivity that everyone uses out into a field in the middle of nowhere. We ended up with 2 times 1 gigi uplinks to the campsite, 1 gigi to Telta, a local telco, and a 1 gigi back to Berlin, where we picked up various networks here in Berlin. The fibre was 4 kilometers through the woods. We were pretty lucky because after all that there was only like 20 meters of fibre left on the end of the spool. And we didn't really fancy picking up and moving the data center container to make it reach. We used peak around 1.2 gig, something like that, which is lower than Congress, but we obviously had less available. So what hardware did we use? Well, we had Juniper MX80 as a BGP router. We speak BGP with all our upstreams. We had some Force 10s as core routers, and in the Hack Center Colo, which is always a busy place. And we actually, for camp, we had the opportunity to buy a lot of HP access switches, which was quite nice. So there's a sort of big pile you can see on the right there. And we also had use of 12 Hirschmann, which are industrial Ethernet switches, which we used in a ring configuration around the site. This is the first draft of the build-up, kind of a nice little sketch, trying to work out where to run fibers. Do you want to talk about that?
Yeah, this was the first draft we drew at the CCB when the whole campsite was fixed and most of the things were placed. This is one of the end. We have running a single mode 10 gig link around here, which was a ring. We run on the link Hyperring protocol, which is a Hyperring redundancy protocol of Hirschmann. They run beacons every 10 milliseconds, and if one side fails, one link, then it swaps the whole ring to the other side. Here we have a 10G spoke, and we ran single mode fibers here. Most of the fibers on the campsite were multi-mode, except the whole ring around the F area. These are the blue things, are all the data flows, and we have 3 cable bridges up here, and we changed we rerouted stuff because here they want 10 gig, so we laid an extra fiber around the Angel area to our data center. Me splicing, we did around 120 fusion splices because we bought the fiber on a cable and we laid them in the ground, cutted them, and then we have to make pigtails on it to plug it into switches.
One of the problems is that it's obviously quite a difficult environment to install fiber, and you can't easily buy cable with connectors that will handle the sort of stresses of installing everything in the ground. The splicing is quite a kind of laborious task, really. So it's nice to have a seat.
It was like 2 days from getting up till sleep, done with splicing. Really boring, and we had around 3 kilometers of fiber to dig around the campground, and it has to be like 20 centimeters deep, that no one puts his tent packs into it, and we have no cable breaks. So we built a plow. On the left, you see the first version, which broke several times. We fixed it several times. And after all, we put it in the front of the Radlader. and yeah, with a chain and some straps and everything. This worked in very good, and we can drive with like 2 or 3 kilometers per hour through the campground and dig a really deep,
ditch.
Yeah. To the wireless deployment, we run a Cisco VLC 5508 as wireless controller, and we have around 6.
Can you do
50,
sums?
Not really. We have around 50 APs deployed, so we had a wireless coverage over most of the whole site. There are some holes in between in the Angel area and the workshop hangar because we don't map the hangars with the walls correctly into the map, which is a bit difficult. Yeah, we had a big challenge. The access points have to be protected against rain and UV, and it has to be 2 or 3 meters high to get with us race over all the caravans. So we fixed something with like some tubes and buckets and a lot of cable ties.
The internet is a series of tubes.
Yeah. And yeah, this was how it looks. And the access point is then just, there's a 90-degree stuff in there, and you can just mount the access point with cable ties horizontal.
It's because they're designed for installing like in a building like this on the ceiling. But when you're at the camp, you don't have a ceiling, so we kind of had to make our own.
Yeah, this was our data center. It was a bit of a fuck up. I talked with the guys, and it was a company which deploys normally data centers in a container with raised floor, air conditioning, power supplies, and everything. And it was a big thing of miscommunication, and so we got an empty shipping container with 2 Ritter racks and 2 air conditionings like you have at home with split devices. So yeah, this is our data center rack with all our NOC stuff. There we have the E600 on the top. We had to fix some uplink splices. Then we have the MX80 as BGP router, the Hirschmann as Hyperring middle node, then some servers and the wireless controller and UPS on the bottom. This is a short movie. We built a weather map, and there you can see how the network expands, and you see the nice traffic flow.
We'll put this online somewhere if anyone's interested.
Yeah, it's available in the Pentabuff, and it will get bigger in a few seconds.
Because we were editing this video on the fly as we built the network up, we added a new box, we changed the weather map, and kept on adding things. So this video, it basically covers the whole timeline of us building up the camp, all the visitors arriving, and then basically to the final day. Yeah, we start moving some things around. Basically up to the top here is the uplink connections.
Yeah, and we moved the 2 routers up there are normally placed in the hack center and the data center, but then there were no place left on the map.
Yeah. And you can see the kind of the uplink one, it gets kind of busy towards the towards the end of the camp.
Yeah, and there you see the links here switched. There we did a test if the Hyperring protocol works, just unplugged one fiber, and 10 milliseconds later it was on the other side.
There's some nice congestion down here. These people down in this area of the field were obviously downloading quite a lot and uploading quite a lot. This is just a single 1 gig link, so we did manage to. There's only so many things you can do, like installing new fibers and things like that. We do sort of re-engineer the network while it's in flight, but to kind of upgrade where required. But it's not always possible.
Yeah, and this was the state at the end of the camp.
Yeah.
We had a few problems on the site. We had Pinky and Brain, our main boxes for DNS, DHCP, and such things. They had a hard disk failure, both boxes. We think it was on the transport or something. So we lost one time the whole lease file, which was not so nice. And we had a big thing with the Cat5 cables. They have a shield on both sides, and on the campgrounds there are several ground potentials with a big difference. So when you lay a cable from the outside of the Angel area inside the bunker, you have a big difference. So yeah, we have to disconnect the shield at one side because there are just too much power on it.
Yeah, you might feel a little tingle actually when you're plugging in the cable, and that's kind of an indicator that something might be a bit wrong.
Yeah, it is our data close for the next event.
Yeah, I think we might need to get the access points a bit higher, so just have some thought about that.
So this was the camp stuff.
That's the end of that. We'll just move on to the review of this.
And now of the current network of the Congress. We will just go over the topics uplink, core distribution, access wireless, colo, monitoring, some abuse and VPN, and some rules at least. At the uplink, we had this time 2 times 10 gig over CVDM system. We got 2 times 10 gig transit in a data center in Tempelhof from KPN and Hurricane Electric. And there we also patched 3 1 gig E transits from Eurotransit, Carrier 51, and peering with our permanent CCCAS. Also, we are in the peering LAN at Berlin. There we dropped off around 500 meg traffic to Kabel Deutschland there. We used a Brocade MLX4 as BGP router, which placed in the data center, and then had a leg to the BCC. You want to start?
So yeah, we had quite a collection of equipment this time around. Coming in from the network, we had an MX80 with 20 gig going out each direction, basically into the out to the internet, as it were, and into the middle of the network. Force 10 E600, so similar to CAMP, and we had some Cisco 6509s. Now one as routing and one as a switch for our kind of requirement for lots of 1 gig E copper ports. We also had some 2960Ss, which are like small Cisco 1U switches, 1 gig as a stack in B90.
Yeah, and C57, which is the biggest patch room in the house. We have around 200 patches to do there. The whole C and the big part of the B ring arrives there. Yeah, the 6509 was a bit difficult this year. At first we had the wrong fan blades, since someone would ship the right fan blades, but it was the wrong fan blades again. Then we got the right fan blades, but then the power supplies were not enough. So we have to get like on the 22nd 2 power supplies in Berlin, which was quite difficult, but yeah, it worked.
Cisco have been shipping these chassis for like 15 years or something, and it's one of those things where you have this broom and you've replaced the head like 10 times and the handle 10 times, and yeah, it's still the original chassis, but all of the individual parts need replacing in it. So because we had kind of had the old fan tray, it's like, yeah, the newer line cards and draw more power and need more cooling and all this kind of stuff.
Yeah, there's a network map of the current network, and on the left you see our uplinks. We run all BGP, we speak all BGP with our uplinks. At the MLX and the Alwin counter, we terminate everything, and on the inside, we choose to only run OSPF because we don't need full tables. Last year, we had a ring we had an additional link between A87 and A85.
Really?
But the file was too broken, and we are too lazy to debug it again. And it's like every year we debug it, and it runs for several minutes, and then CRC errors. Yeah, you see the router behind A85. We had 2 colo switches, which were connected with 10 gig Ethernet to A85 and distribute 1 gig Ethernet ports down. And the VLC, the wireless controller, with an 8 gig lag. These are some uplink stats.
Everyone loves graphs.
Yeah. We had around 23 gigabit uplink. We only used 5. So use more bandwidth.
Yeah.
No, top 5. With the top ASN we make traffic to, we were heavy outbound. We had like 5 gig outbound and 1 gig inbound only. Most traffic goes to DATAC and Hetzner, and also to some smaller access providers or bigger. And yeah, the only content provider was Hetzner. The rest was only leeching from us, and yeah, was outbound traffic.
Oh yeah, so talking a bit about the wireless LAN, yeah. Again, this is quite similar to what we did at the camp. This Cisco lightweight controller solution has been working really well for us. I think this is, what, the fourth time we've used it? Third time? Third time, yeah.
I think.
Yeah. This basically, because it's more central control of how clients roam and things like that, it is really made a step change in the quality of the wireless LAN we can provide. So again, it's much the same, just a smaller number of APs here in this occasion than at the camp, because it's a smaller building. We did find some bugs. We had to put a IPv4 ACL inside the controller, and that actually broke IPv6. And there's actually quite a lot of IPv6 use now. The usage on the network is something like 7%, which was quite surprisingly high and is really kind of heartening for those of us that are trying to get IPv6 deployed. So maybe we should just start saying use more IPv6 bandwidth rather than something like that. And I guess like the fact that people are reporting like they're leeching stuff at 30 megabits a second and video chatting and so forth on the wireless means that's kind of a good indicator that it's working quite well for a lot of people. It's quite a challenging environment with the density of devices, but
here are some stats.
Oh yeah.
We had around 1,350 simultaneous users as average, and with around 19 users per access point. Our biggest access point, I think, was in the hack center with 140 clients. We detected 3,300 unique wireless users. And
so that's more than one device per person, just for... I suppose when I think about it, I'm probably carrying like 4 wireless LAN devices, and many of you will be as well, so it's not so surprising.
Yeah, then you see the client distribution, so the most people are using 11.n in the 2.4 gigahertz band, but the most traffic runs over 11.n in 5 gigahertz band.
Yeah.
Like it was the half of all the traffic.
I think that shows how much better the 5 gigahertz band is, and it's something when you think about when you're buying new hardware, is you really want to look for that 5 gigahertz capability, because you just have more oomph there, more stuff available.
And we turned off 11B again, like at the camp, because it's only slowing down, and 2.4 gigahertz is so crowded. Yeah, there's some statistics, like some traffic peaks around the afternoon, the evening, and yeah, the client counts.
It's quite good, because when people finish using their Wi-Fi devices, go to sleep, you can really like see when people have left the Congress, when the devices are no longer associated, far more so than you see with traffic.
Yeah, the co-location, I just mentioned it. You have 2 switches, 2 times 10 gig each. It was smaller than last year. But the cases, they are really crap. One time I had to carry out a server because of abuse, which was a box with a switch, 2 plugs, and tons of cables, which is not nice to carry. Or some things like this, the smallest hit on the case will make that the hard disks crash. So get better cases. Yeah, this was our motto for this year. We want to monitor as much as we can out of the network. So we built our dashboard. I saw this at DreamHack, and I want this for the Congress too. So we started with bandwidth. The clients connected the POC and the streaming clients. Then we added a radiation level, and then the wireless bandwidth usage, how many open beacon rockets are in the network, and IP protocol distribution. Next year we will run all this stuff from the beginning, and so the graphs are bigger and fancier.
And if you've got any other ideas of what we can monitor easily, then we could add that.
Yep.
I mean, I don't think we have some kind of martyr consumption sensor, but that could be useful.
This was a weather map of the current network. You have on the left the uplinks, then the BGP router, and then the intro network on the right. We had a 20 gig connection between most of the switches.
Yeah, so all this is 20 gig, 2 times 10 gig 10 gig set of links there. And I think we kind of needed it with the peak utilization there.
We don't have much congestion, and yeah, we had about 8 or 9 gig between the hex center and the core router upstairs. This is our Isinga map. We used Isinga for monitoring. Isinga is a Nagios fork. We had around 200 hosts monitored with around 1,100 services. We monitored all the equipment like servers, routers, all the access switches and the access points. And additionally, the environment that we unplugged some switches, some fans at some switches, that they don't get too hot, or the uplinks are that they are always some stuff left. And we have a quite annoying IRC bot for alarms, which are just talking every time, hey, an uplink port is full, or here are some too much max and such things. We used also AS-stats with a small Perl packet for S-flow analysis on AS-base. We used MRTG for all the graphs, and we used ring.nlnoc.net, which is a project where you share servers with some other ISPs, so you can debug the network or some uplinks doing trace routes.
So this big graph here, this nice pretty colors and everything, is this is actually the the network traffic to and from individual networks, and this is based on our KPN uplink. So we were sending quite a lot of traffic to DTAG. That's all this stuff here in the red. But this is really useful for us when we need to do some traffic engineering. We need to balance where we're sending traffic.
It was quite easy this year because we had around 20 ASNs which have a huge load of traffic, like between 100 and 600 Mbit, and was really easy to shift the traffic to another uplink because just you shift it and 200 Mbits are away from one uplink. Yeah,
it's a really useful tool, this, and really good for us to know where we're sending traffic.
We had some abuse. 2 things. Was an online shop who was lost via an exit node via the PHP 0 day of Alech, and a news portal. Yesterday night at 6 we had a DOS against our DNS and DHCP server from the Amazon EC2 cloud. And all of you DOS events CCD, which was a quite weak setup with an Apache 2 and nothing more. And now it's a Varnish and Nginx and Memcached, so it should take the next Congress better. We ran a VPN with around 20 beacons of the Congress, which are hacker spaces who want to participate here. They did a peak traffic of around 150 megabit. We also had a DN42 and case VPN peering. We have some rules for you for the next time. If you have a switch on your table, don't unplug it. We monitor the switch for everything, and we have a tagged VLAN on the first port, so when you change the uplink port, the switch won't respond for us. If it's too loud, or do you want to replace it with a switch of your own with more gigabit ports, or you need a quiet thing, just talk to us, because if it's too loud, we can just unplug the fans. They are robust and not very warm. And when you want to replace it, we just remove from our monitoring. And all the wall sockets are usable, most at 1 gigabit ports. And down in A, it's the only floor where you have only patched every second port because we don't have enough patch port on the Cisco there. Yeah, some questions?
This was a nice This photo was actually from the camp, but someone left us a nice message, so thanks for that. It's nice when you're kind of walking through all this mud and getting yourself filthy, clearing up, and find a nice message from someone, so thanks.
Well, thanks to you to keep our central nervous system running here, our network. Do you have any questions? Please raise your hand and wait for a microphone to come to your place. Any questions? Sorry, standing in front of the loudspeaker. And do we have questions from the internet yet? No questions? How about back of the room? Just raise your hand if you have a question. Yes. Microphone is on its way.
Hey, I have a question to the camp. Is the fiber still laying on the gram count?
No.
The ground? No.
We collect them all, put them on spinels, and put them in the storage.
The uplink too?
No, the uplink was going back to the provider, and they are digging them anywhere in the cities there.
We actually reuse some of the fibres, so some of the fibres we use, there's a kind of big pool of them, and some of them are as old as HAL 2001, if any one of you were there, and they kind of get used every couple of years or when sort of required. So we don't throw this stuff away. If it can be reused, then we will reuse it.
Okay, then we have a question from the back of the room. We need a microphone to get to this place. In the meantime, just let me announce you for the English-speaking of you. We have a translation of the talk Security Nightmares on DECT 8004 later. So it's a talk in German, but if you want to listen to it in English, there will be a live translation. Now here's the question.
Okay, first of all, thank you for your work. And I would like to ask if you have any documentation for your monitoring stuff. Because I want to use it on my own network.
Yeah, we have some wiki for NOC internal stuff with the scripts, and we are thinking about doing a small public page with all the NOC talks and scripts we use.
It's quite an interesting question, actually, because this year after camp, we realised that we sort of reinvent the wheel every time. So.
It could be useful for two sides.
If you have any special things, just mail us you want to have, and I think we can get you everything.
Yeah.
Okay, another question from up here.
Also, thank you for your work very much. How many people are working in the NOC team?
We were not so much this year, but we were around 10, 15 people who were there at the Congress.
And when did you start setting up the network?
In the BCC we start on the 23rd. I deployed the uplink router on the 18th December or something. And the first patch for the first KPN 10 gig link was around October in the co-location.
Okay, so Christmas was a little hurt.
Yep.
Well, any more questions? Yes, over there. Thanks for getting it. Right over there.
Have you considered adding encryption to the wireless?
No, not really. You can use a VPN or something, it's just too much load, and yeah, everyone can encrypt his servers at his own, and yeah.
Okay. There's one more question, yes?
Is there any interest from the companies manufacturing the equipment, say Cisco, HP, in how well their equipment performs? Are they interested in it?
Not really. It was quite difficult to get some hardware this year because the process you have to find someone who would like to sponsor for Brocade. I proxied with a company for this event because the management there won't sponsor the CCC officially. And so it was for other companies which I just want to stay unnamed, and was more or less from carrier pools or something, and not directly from the vendors.
We have in the past, we've had a lot more sort of relation, generally with individual people in vendors that actually come here and are interested in what happens here, and that can be really valuable when you have someone on the inside as well. But they come and go, right? It's not an official activity, but it's nice.
Okay. Up front here.
Hello. To answer the question about wireless and encryption, there's actually not much we can do about that to provide you with encryption on the wireless, because even if you put a pre-shared key on the wireless and give it to every Congress participant, everyone who has this private key and witnesses and captures the package of your first association can decrypt your session keys, because they are derived from your pre-shared key. So we would have to set up an account on a radio server. So, and everyone would have to use that account to associate to the encrypted network. But this is a lot of this provides a lot of work for people and for the help desk, because some wireless clients do handle handover between wireless stations in encrypted networks quite poorly, especially if there are many networks and substations available, like at the Congress. So if you are concerned about your privacy on the wireless network, which you should be, we can only recommend you to use a VPN service.
Okay, last two questions.
Thank you. So at DEF CON, they have this thing called the Wall of Sheep, where they monitor all the traffic and the wireless traffic, and then they print all the passwords and usernames that are sent plain text over the network on a big wall of monitors. And have you thought about bringing something like this to the Congress?
We don't monitor your traffic. We don't look in the contents of your stuff. We kind of take this sort of privacy stuff quite seriously, I think.
Yeah, last year we had a privacy officer who checked all our servers that we don't log too much, and we're just giving a high level of privacy everywhere. Like we have encryption on every server which has user data, and the first one, so we have no backup server for DHCP at the moment because the first one is already wiping. And yeah, we don't want your user data because it will make problems at any time.
Sometimes we have to record or temporarily store user data for the operation network. I mean, a good example is the DHCP leases file that contains your MAC address, your IP address, stuff like that. And we have to put that on a disk, right? But we're quite careful to wipe that at the end of the Congress. And we really, I don't think I think we feel strongly that it's not our job to be looking at the contents of people's packets.
What's the usual legal fallout? Will someone be getting a bucket full of lawyer mail after each event?
No, we just get only a bucket full of automated stuff, like Sony says we should stop torrenting stuff. I still get things from the Congress network which were torrented yesterday, and this is the IP range we gave them back 1 year ago. And we get lots of stuff from the automated things like IDS and something from Hetzner, where you say, oh, you're doing FTP, and that's bad.
So actually, the address block we get is a temporary address block, and it changes each time, and it's actually then assigned to someone else. So it's pretty likely that we keep on getting the abuse mails, but it's actually not our abuse at all. It's like whoever owns the net block now. So they're really, really poor at keeping like their WHOIS data updated, and there's no excuse for it, right? But unfortunately.
Maybe just a short comment. If you log into Gmail account and look at the last activity of your account, you see all the logins from the IP address pool from here, and it's associated with Russia. Yeah. And a friend of mine was very confused. Oh, my account was hacked from Russia, but it was himself.
Yeah, on camp we had the same problem. I think the net block was located in Denmark.
Yeah.
So yeah, it just takes a few months till it's located in Berlin, and with temporary blocks it's difficult to get a correct geolocation in a few days.
Yeah, because of the short time frame. And again, when you go to the main google.com site, you get some Russian characters. Oh, well, keeps life interesting.
All right, well, I think that'll wrap things up. Thank you very much. Thank you very much for keeping the network running.